Hello everyone. In this video we're going to go through applications of polynomials. So just 3 questions with cubic style application questions. They tend to be the volume of a box, but you can have other things, but we're just going to focus on looking at application questions that involve the volume of a box, because when we did quadratics we kind of looked at the area of a farm or something. So, you're looking at area, 2 dimensions, and now we're looking at volume, 3 dimensions. So that's why it's a cubic. We've done one of these in class, so we're going to do 3 more, and I'll do my best to explain it. I'm going to kind of split the screen in a second so we can see the question, am I working out in one go? And we'll see how we go. Anyway, let's get started. So a rectangular sheet of metal measuring 10 centimeters by 12 centimeters is to be used to construct an open rectangular tray. The tray will be constructed by cutting out 4 equal squares from the corners of the sheet as shown in the diagram to your right. All right, let's get my highlighter up. So what we've got here, the key is this little square on the side. All right, and it's a bit hard to see there, but basically if we were to make a box, think of a cardboard box or piece of cardboard laid flat, and if you wanted to turn it into a box, you got to fold the sides up. So if you really want to, you can go and open up a tissue box or a shoe box or something like that and see, you fold your sides up. So basically our height is going to be x, and our length and width come from, well, they aren't 10 and 12 because that's what it is when the cardboard is laid flat, but that's going to help us calculate the length and the width. So you can see up the top we've got L. So this length here is going to be 12 minus 2x. All right, so just the length from here to here, because the arrow probably shouldn't go that far. Let's just cut that off to there. And then the width, I don't want to do W. The width is, I should be concentrating, 10 minus 2x. And that just goes from here. So instead of being the whole 10, we're going to have to subtract a distance from each corner, and that is x. And we don't know what that is, but because each length has 2 ends, that's why it's 2 times x. All right, so I'm just going to reduce that, and let me just, trying to be fancy. All right, so just so we can see it at the same time. All right, so for question A, we've got, if the edge, and I might just put 2a there, if the edge of each cutout square is x centimeters, express L and W in terms of x. So L is equal to 12 minus 2x, and W is equal to 10 minus 2x. All right, so that's not too difficult. Part B, write down the rule for the volume. So the volume of a rectangular prism is length times width times height. So for this one here, we've got 12 minus 2x. Now, whenever you're multiplying multiple terms, you've got to give them a big hug. All right, give them some brackets, because otherwise, if you don't, you might read it as, what's W? 10 minus 2x. And then we're going to be multiplying x. And that is a completely different equation to what it would be if you put brackets around it. So please make sure that if you're multiplying multiple terms, that you just put brackets around it. All right, so that's the rule. All right, that's what it is in factorized form. If you wanted to expand it, you can just do FOIL. So front, outside, inside, last, or on your calculator, and here is one I prepared earlier. We could just go to interactive transformation And where are you, expand? There you are. And then we just put the expression in. So 12 minus 2x, 10 minus 2x, and then we're multiplying by x. Now I haven't put multipliers in between there. I wonder if it cares. Okay, doesn't, which is good. And there it is. So that's going to be equal to 4. Oops, don't want green, sorry. Okay, so 4x cubed minus 44x squared plus 120x. And you can see we end up with a cubic, which is what we want. Awesome. All right, part C. Use a CADS calculator to help draw the graph of V against X for suitable values of X. All right, so let's just look at what our x-intercepts and our y-intercepts are first. So I've got my volume equation both in, this is in expanded form, and then this one is in factorized form. So when we want to find out our x-intercepts, we need to let, in this case, v equal 0. So solving that, you do need to factorize it. So that means 12 minus 2x, 10 minus 2x times x. Usually we put the x out the front, but I'll just leave it at the end, equals 0. So we just use the null factor law to solve for x. So the null factor law just means if the right-hand side is equal to 0, that means something on the left-hand side has to equal to 0 because you're multiplying everything. All right, so let's just solve for this. So this is going to be 6, and this one's going to be 5, and then we've also got x equals 0. So we've got x-intercepts at 6, 5, and 0. Just make sure that's right. 12 minus 2x, 12 minus 6, 12 minus 10, good. All right, and then your y-intercept, now if you've got an x-intercept that's 0, then your y-intercept is also at 0. If not, it's your constant, and the constant here is obviously plus 0. We don't write it on. And when we're sketching, okay, it did say to put it on the calculator, so let's do that. So menu, graphs and table. Okay, so we don't want you anymore, sorry, bye. All right, I'm going to put the factorized one on, 12 minus, and I could have just copied and pasted that, to be honest. Should have done that. 12 minus 2x times x. All right, and oh, I can't see it. Well, no wonder I can't see it. Look at my scale. So that's an old scale. You can go to resize. Still a bit hard to see. Actually, no, that doesn't do it. That just makes the screen bigger. We can go to zoom. Go to zoom standard. Still a bit hard to see, but we can see our x-intercepts. So one's at 0, and then you can see the 2 at 5 and 6. But another way you can do it is just go to gsolve root. That will give you your x-intercepts. So there's your first one, 0, 5, and then 6, like we expected. And we can't see the top of the graph, so just to change your window, see where my arrow is, pressing that button. And I'm just going to make my Y max a bit higher. So I don't know what to make it, 50? Is that going to be high enough? No. 150. There we go. A bit easier to see. Actually, we know our y-intercept is at 0, but if it wasn't at 0 or you didn't know it was at 0, you can just go to y-intercept there. All right. And then the last thing we need to do is our max. And there it is. So when you're sketching it, always think about the problem. So this is a volume problem. We can't have negative volume. So with this graph, we only really want it to go from 0 to 5, okay, because we can't have a negative volume. So anything below 0 is going to give us negative volume, and that just means your cardboard doesn't exist. And then anything after x equals 5 is also going to be negative. And then it does become positive again, but yeah, we're just going to stop at 5. Okay, so get the question up. What was I meant to do? I'll draw the graph. I'll draw the, yeah, draw the graph. All right, so draw your axes. I'm going to do them in green. And we've got x-intercept at 0 and y-intercept is also at 0, 5, and 6. I'm just going to draw it from 5 to 6. Okay, it went something like that. What was our turning point? 1.81 and 96.77. So 1.81. Oh, I was trying to memorize it and it stays on. 96.77 is our turning point. All right, which is there. All right, so if we just scroll down to my answers, all right, so you can see they're a little bit better than mine, like the scale or the shape of it looks a bit better, but we're just learning cubics, all right? So it's completely fine that my graph looks slightly different to this one, but there's nothing incorrect with what I've drawn. All right, still got the turning point. Actually, maybe that turning point, because it's not halfway between 0 and 5, I probably should have it a little bit more to the left, but it's all good. Okay, let's go back up. All right, so find the value of v when x equals 1. So I might do, hold on, let me just label this because I want to save these answers. So there's C, which I already wrote. We'll do that there. All right, so the answer for D. So when x equals 1, you can just substitute that in, but I'm going to do it on the calculator. So you can do it on your graphing screen. You can go to just trace, and all I'm going to do is press the number 1, and it comes up. And go, okay, and I get 80. All right, so when x equals 1, your volume is 80. You could also get 80 just by substituting it into your equation. Then for E, so V equals 50, and we want to know what x is equal to. So what we can do on the calculator again, I don't think we can actually do it from here. Let me just check. What's that? Okay, there we go. So when y equals 50, x is equal to 0.51, or just to 2 decimal places. I'll just show you what I just did. So analysis, G-solve, and then x calc or y calc. So just depending on what you're after. So we're after the x value. So that's why I pressed that, and it was asking for the corresponding y value. Now, just with something like this, you've got to be conscious of whether it's asking you to round or not. So when you're using your graphing screen, it's always going to give you a decimal answer or an approximate answer. So I'm just going to highlight this because I don't want to copy it. So write it out again. Now, if we go back to our main screen, you can get your exact value just by changing your decimal to standard. So if I wanted to do the, oh, well, okay, get rid of that. So I was doing something else. So we're still doing question E because question D it already gave us an exact value, so that's fine. So we just go to solve, put your equation in, and we're going to let that equal 50, and we're solving for x comma x. Oh, what's going on there? Did not expect that. Let me just see if I can clear everything. Let's see if it's going to make any difference. All right, start that again. Did not expect that to happen. Equals 50, comma x. Okay. All right, so obviously it's not going to give us a nice exact value, so rounding it is fine. In this case, that's very weird. I wonder if I did anything wrong. I don't think I did. All right, so if we put it back to the decimal, let's see. what's going to happen. There we go. All right, so we do get multiple solutions. All right, so you can see we've got x equals 0.51, x equals 3.5, and then we've also got x equals 6.9. And that's because if I go to my, oops, not that, to my graph, it's going to cross, so I'll actually just draw that line. So x equals, I'm sorry, v equals 50. See how it's crossing at 3 points? 1, 2, 3. So when v equals 50 at 0.51, and we actually should put in that second point as well. So let me just do that again. So it's probably only giving us the first answer, isn't it? All right, see how it's flashing? So that just means it's asking what graph? Yes, I want that one. We want 50. And I just need to move my cursor to get the other one, which I should have done before. So what is that? 3.56. Now, whenever you're solving on your calculator, see how we've got three solutions. Go back onto my calculator. 3 possible solutions. The only relevant ones for this one are the first 2, because our domain is going from 0 to 5. We're only looking at x values between 0 and 5. So x can't be more than 5. So we can't say that that's a possible value, which is 6.93. All right. Find the maximum volume of the box and the value of x. All right, so that is your turning point, which we've already done. So when we did our graph up here, 1.81, 96.77, that's actually our maximum. Now, if we wanted to do the exact value, we'll do that in a sec. So the volume max is at, it's 96.77 centimeters cubed, and that's when x is equal to 1.81. Go back to the calculator. So going back to the main screen, if we wanted to do it here and get an exact value, we'll see what we get. Hopefully nothing with all that trig stuff going on. I always go to the wrong one. Calculation, we want, what do we want? Max. Type your expression in, and we're only going from 0 to 5. All right, so there it's written it in, exact form, but it's not the prettiest. So you can write that, or you can just do the decimal approximation for this question. But if it says in exact form, or it doesn't say to round, then you do need to put it in its exact form. Okay, moving on to question number 3. The outsides, actually I'll make it bigger so you might be able to see. All right, so the outside surface area of an open box is 75 centimeters squared. The base is a square with each edge x centimeters. Let h be the height of the box. Find the surface area of the box in terms of x and h. Hence find h in terms of x, blah, blah, blah. So it's pretty much the same thing. The only difference is we don't have a diagram for this one. But, you know, if we're doing a box, then it's not hard to draw. Okay, so let's draw it quickly. It's going to be a square box, so do your best to draw a square. So the surface area, so the outside surface area of an open box is 75 centimeters squared. The base is a square with each edge x centimeters. So it's a square and they're all x. Let h be the height of the box. So again, this is going to be h. All right. All right, I'm going to start this question again because I just paused and had a good read of the question. I think what it means by open box is different to what I was interpreting as an open box. So I think the open box is just a box without a lid on it. So if you think about maybe a pizza box without the lid, Okay, so I'm going to draw the box. All right, so it is open. All right, so our total surface area is 75. That's why I got a bit confused before, because I was like, oh, that's not going to work. All right, so this is X, so it's a square base box, kind of like a pizza box is square, and the height is H. So what it just means by open box is it means it doesn't have a lid on it. Okay. All right, so question A, find the surface area of the box in terms of X and H. So with this box, we've got the base plus 4 sides, and the sides are equal because the base is a square. So the base is X times X, and the 4 sides, so if I color in one side, right, that's just going to be 4 times X times H. So let's just tidy that up, X squared plus 4XH. Right, so the blue side, there's 4 of them, that's why it's multiplied by 4, and the base is a square of length of X, so X squared. All right, part B, hence find H in terms of X. So we know that the total surface area, so the total surface area is equal to 75, and we worked out the area formula before, and find H in terms of X. So we just need to put everything other than H onto the other side. So I'm going to subtract X squared. So bye-bye. So I'm left with 4XH equals 75 minus X squared. And then I'm going to divide both sides by 4X. So I'm left with, and I might just write it on the side here, H is equal to 75 minus X squared over 4X. Right, so I'm just checking my answer. So you can see in their answer, they've taken out X as a common factor. Sorry, I was looking at the wrong one. So you can see down here at B, so 75 minus X squared. So I was just checking my answer. Okay, moving on to C. Now we're going to find the volume. So I was looking at the answer for C. So remember, your volume is length times width times height. Now, we did length times width before. That's the 75. Oh, actually, sorry. No, we didn't. We did the base is X times X, and we did the height before. So this is H, and this is H. So we can just say, all right, if H is equal to 75 minus X squared over 4X, just make sure you put it in the 75 minus X squared in brackets, and then we can just cancel one of these with one of them. So then we're left with X times 75 minus X squared on 4. And if you want, you can expand that bracket to be 75X minus X cubed over 4. All right, question D, find V when X equals 2. All right, so let's do that all in one go. So X equals 2, V equals X equals 5, V is equal to, and squishing down the bottom there, X equals 8. All right, so you would just substitute those values in to get V, but we can do that on the calculator. All right, so get my keyboard up. So we just want this fraction button here. So 75X minus X cubed over 4. And instead of defining it, you can just write it and then use this button here, which is called given that, and X equals 2, press enter, so 71 over 2, which is 35.5. And what are we dealing with? What units? I'll do that in a sec. All right, then the next one is 5. So what's that? 62.5. And then 8. 22. Don't have to worry about that one. All right, and what are our unit centimeters? Centimeters cubed, and centimeters cubed. Given that v equals 59 when x equals 4, find the other value of x when v equals 59. So again, we can just do that on the calculator. So I'm going to highlight this, copy, and then go down here and do solve. Equals 59, comma x. All right, so we've got the exact value there. So we've got 4. Find the other value. Let me get my calculator back up. So I can see it's in surd form. So we've got -3 root 7 minus 2. And then 3 root 7 minus 2. So if I go to decimal, press enter, then you can see we've got 4, -9.93, and x equals 5.937. Now always think about the relevance of your answer. So x is the base length. We can't have a negative base length, so the only other possible value is 5.94. Or if you wanted to go back and do the exact value, you can. Now you can just see they've worked it or solved it down here, but we can just use the calculator. All right, moving on to question numero 6. All right, so a reinforced box is made by, so this beautiful picture, great picture. A reinforced box is made by cutting congruent squares of side length x centimeters from the 4 corners of a rectangular piece of cardboard that measures 48 centimeters by 96 centimeters. The flaps are folded up. So you can kind of see from the diagram on the right what it's going to look like. So you've got, let me just get my highlighter. So this part here is kind of the flap that's going to go over the top, and this part here and this part here are kind of folding in on the sides, which is a bit more realistic with how you would actually make a box. And then these red parts here that are now black, they get deleted or cut out. All right, find an expression for V, the volume of the box formed. All right, so let's do the working out on another page. And I need to make that smaller, don't I? Oh, seriously? I even had you on black. Okay, find an expression for V, the volume of the box formed. So let's just have a look here. We've got 96 on the bottom and 48 on the side. So we're going to have our length, the length is going to be 96 minus, now why has it got 4x? Sorry, I just had to have a little bit of a brain break. 4x. Now, just going to go over that with the drawing. Might highlight it a different color. Let's do it in yellow. Okay, so we've got the 96, and we're going to be subtracting this part here, but also this one, because we only want this length of the box. All right, so we're kind of this part, oh God, it's not really that good, is it? Let's do a different color shading, pink. I reckon pink's going to work. This part is folding up. So it's going to be 96 minus 4x. So we've got x and x and x and x there. So the length is 96 minus 4x, and the width is a little bit easier because you've only got one x either side. So it's 48 minus 2x, and then your height is just going to be x. All right, so the question does ask for the volume. So volume equals length times width times height. So 96 minus 4x, 48 minus 2x times x. You can expand that if you want to. It doesn't say to expand it, so I'm just going to leave it like that. All right, so like in methods, if you doing the exams in year 12, you would just leave it in factorized form. You don't need to go ahead and expand it unless it asks you to expand it. So we'll just leave it in factorized form. Plot the graph of v against x on your CAS calculator. All right, so you can go ahead and let v equal 0 to find your x-intercepts and find your y-intercept by letting x equal 0, but I know that because we've got this one here that your y-intercept is also going to be 0. All right, but let's graph it on the calculator anyway. All right, I might use define this time just to kind of reinforce that you can use, you can define a function and use it multiple times instead of copying and pasting. So 96 minus 4x, 48 minus 2x, and then we got times x. All right, and then we say Dunskies. All right, now what was it? What were we graphing? Okay, what we're doing. I don't even know which button to press. Menu, graphs. All right, so let's clear them. Yep, I'm sure. All right, and then instead of typing it again, you can just do f of x. All right, oh my gosh, I can't see it. So you can go to auto. Still can't really see it too well. So we can just change it. So I can see that my maximum is fine, but I can't really see my x, so maybe we can go as far as 30. How does that sound? Looks good, looks good. And we can see that there's some x-intercepts happening here, so I might just change, excuse me, no, back onto there, my y-axis. So my y minimum, maybe make it -20. Gosh, it's high. I don't even know what to change it to now. Didn't expect it to be that high. Let's see how we go with that. All right, might need to make it a little bit higher. Let's make it 20. Should I make it 18? Because I think we're nearly there. Okay, so now we can see the whole cubic. It was a bit hard to see before. So were we sketching it? Quickly sketch it. Oh, didn't mean to have highlighted. Okay, so it's going up and then down, and we just stop there because we only want to go, it's a box, okay? So we get the gist now that we only want positive volume. All right, so first x-intercept is at 0. We need to get the other one. So let's go to gsolve, root, and then just move your cursor across. What is that, 24? And we'll get our maximum value. So, oops, go back onto my calculator and I just scroll it. Is that a, oh, it's a repeated factor. Okay. So there is only at 0 and the other one is at 24 because we do have a repeated factor in 48 minus 2x. So I might just show you what I was talking about. So if I've got 96 minus 4x equals 0, that if I divide by 4, I'm going to get 24 minus x equals 0. All right, and then if I do the same with with 48 minus 2x equals 0, and then, all right, so see how they're the same thing. 24 minus x equals 0, 24 minus x equals 0. So that means we've got to a repeated factor at 24. So your turning point is actually at 24. I didn't pick that up before. So we've only got the two x-intercepts anyway. All right, and then our turning point, let's just go to max. All right, and there it is at, what is it, x equals 8? It's always hard to see. All right, so our turning point is at 8, 16, 3, 8, 4. Okay, here's our graph. Poorly drawn, but you get the gist. What is the domain of the function v? So v has to be greater than 0, otherwise it'd be a flat bit of cardboard, and the highest it can be is 24. So we can see that from the graph, but if you think about the context of the question, we've got a 48 here and a 96. All right, so we've got to take the lower amount. If we had a side that was 48 and we folded it immediately in half, that would mean that, sorry, it shouldn't be v here. It should be x. That would mean that your height would be 24, and you'd have that piece of cardboard, like think of a piece of paper that you fold in half and then the two sides are touching. That would be your cardboard. So you would actually have no volume because bits of cardboard are touching each other. So it has to be greater than 0, but less than 24. And 24 comes from half of this, all right, half of the 48. All right, using your CAS calculator, find the maximum volume and the value of x. Okay, so we did that before. Let's just write our answer. All right, so the volume maximum is 16,384. What units are we in? Centimeters? Probably. Be a pretty big box if you had meters. And x is 8. Find the volume of the box when x equals 10. So you can substitute it into your rule or just do it on your calculator. So we can go and start using this one. So we want to calculate the volume. So x equals 10. All right, so there it is. So volume is 15,680 when x equals 10. It is decided that x between 0 and 5, x is between 0 and 5, the maximum volume that's possible. Oh, my son's just come home. Might just pause for a bit. All right, so where were we? It wasn't 15, I've got to finish that. So, whoops, not in pink either. So 15,680 centimeters cubed. So question, oops, I was looking at the answers. It is decided that x is between 0 and 5. Find the maximum volume possible. So on our calculator, you can do it by the graphing screen, but it's probably easier to go to the main screen. And I've already defined it. So all we need to do is go to calculation, function, and we want the max. So type in f of x, and we're going from 0 to 5. Whoops. All right, so the maximum value is 14,440. Oh. So when x is between 0 and 5, your max is going to be 14,440 centimeters cubed. And question E, if x is between 5 and 15, what is the minimum? So we can just also do that on this. What? Not going to get angry at the computer. All right, so we want the minimum this time. So again, we can just go to the calculator, but instead of doing F max, we just want F min. Gosh, this rain today is crazy. F min. All right, so again, we can just type in f of x. Excuse me, I said we can type in f of x. There we go. And we're going from 5 to 15. Oh, what did I do wrong? Ah. Okay, so you do need the cursor down here when you do it. Let's do it again. Calculation, we want the minimum. So f of x, 0 to 5. Oh, what? Oh no, it's 0 to 5, 5 to 15. Okay, so when x equals 15, we have 9720 centimeters cubed. All right, and that's it. Bye.